Hello, everybody. I'm Dr. Jesus Nicolas Bermudez, and I'm going to talk about synthesis and characterization of nanoparticles from walnut shell obtained by planetary ball milling. Okay. The next is the work group and institutions and my email contact. Okay. I'm going to begin with the introduction. In this section, we consider three things, three keywords. Okay, the walnut shell, the AFM, and the planetary valve milling. That is the three things that we use to can do this research, this project. Okay, the walnut shell are defined as cellular solid of low density and high resistance. Okay, is similar that the wood. Okay, and another important data about this material is that the shell weighs half of the complete fruit. Okay, so walnut shell is considered waste with little economic value, and the half of this is this fruit, okay, which can have potential as lignocellulosic biomaterial and another kind of materials, okay. And the aim of this work was to obtain particles from walnut shells by planetary valve milling and its morphological characterization using AFM, atomic form microscopy, okay. So the methodology that we use was as following. Okay, we begin with a pre-milling of walnut shells. In this step, we washed the walnut shell with distilled water, and we introduce the walnut shells inside of a coffee grinder to do the pre-milling. When we finish receiving with using a mesh to can separate the fragments from the fragment of walnut shell from the powder. Okay, we obtain fragments about 2 millimeters and a powder in order to micrometers. Okay, and we use a mesh to separate that two materials and collect the fragments, put inside again in the coffee grinder, and we did another again the pre-milling, okay, to obtain more powder. Then the powder obtained from this pre-milling was introduced in the bowls from the planetary valve milling equipment with agate bits about 3 millimeters of diameter, okay. The milling in this equipment was from 3 hours. This time is the effective time, okay, because also we left rest times to release heat, okay, to avoid agglomeration in these particles, on these materials, in this material, okay. So after the milling, we collect and sieving, and again after to milling in the equipment, we collect the powder, and again we sieving this powder to can separate the nanoparticles from microparticles, okay. And then we dilute the powder in distilled water, and we introduce in a ultrasonic bag to can scattering and separate the particles and have a better distribution, okay. We take a drop and place in a sample holder to after we let it dry for later characterization by AFM. Okay, the condition of AFM was in the experiment in air, and we use an tip in taping mode to can collect the topographical images of different scanning areas. Okay, and that was the methodology that we use. Then the results and discussion we have that in the first in the first image, we have some images, the equipment and the powder obtained. That we can mention that we obtain a very fine powder with a light brown color and a high degree of compactation. Okay, maybe it's not possible to see that, but the physical studies that we made can elucidate that. Okay. In another image, we have topographical images of nanoparticles of walnut shell obtained by AFM, in which we can see the size and the scale of from these images. The scale is 100 nanometers, and the size from this particle is about 16 nanometers. Okay, the average size that we obtained was 104.6 nanometers, but we obtained a standard deviation from 7.8 nanometers. So it's a wide range of particle size, which is associated to the condition of the milling. Okay, we evaluate the roughness using the software from the EFM equipment, and we obtain values from roughness that which are about 0.29 nanometers with a standard deviation of 0.097 nanometers. Okay, it's a very smooth surfaces that we obtain from this study. Okay, and the conclusion was that the planetary valve milling was useful to reduce the size of the walnut shells and thus obtain particles with a size in the range of nanometers, also in the micrometers, because we obtained a wide range of the particle size. So we also obtain the microparticles. Okay, the milling condition played an important role in this work because they are responsible for the particle size obtained as well as its homogeneity. Maybe change some parameters about or some conditions in the valve milling, in the planetary valve milling. We can use reduce the range and reduce the size from the particles. Okay. On the other hand, using the EFM technique, it was possible to examine the obtained particles and characterize the morphology and texture parameters in order to offer the possibility that nanoparticles can be used in some application areas. Okay, we are do the another research or the another work to can use this powder to use as a filler in the soft materials to can evaluate the mechanical properties and associate with this filler as a reinforced the mechanical properties. Okay, so this is the final of the presentation. If you have a question, you can do it by the platform or even with my email contact that is up. It's here. And okay, I hope that you have enjoyed this video. Thank you for watching and see you in the next. Bye bye.